In section 9.6, we are solving rational equations. And I think you'll see that some of the skills that we learned in section 9.5, as far as how to find the LCD, using the LCD in a process that we were doing with division into the LCD and then multiplication in the assignment that we just did where we were adding and subtracting fractions. Some of those same skills you're going to see come into play in this lesson. And let me just show you what I mean by this first example. What we're looking at here is very similar to what your first 9 problems look like, where we basically have a proportion. We have one fraction that equals another. But the way I want you to go about solving all of the problems on the assignment is basically like I'm doing this first problem. So there's a lot of repetition, and that's good. All of these problems are basically solved the same way. So the first thing I'm going to do, much like our last lesson, is I want to factor the denominators. Okay, so the blue is just the given red problem that shows the denominators in factored form. And the only reason really for factoring the denominators is to make it easier to find the least common or lowest common denominator. So hopefully you can see, as a review of our last lesson, my lowest common denominator is 2 times x minus 1 times x plus 1. Since these denominators already have x minus 1 in common, I don't need to include it again. So I'm going to take the LCD that we've just identified, and I'm going to multiply by that LCD on both sides of my equation. The goal is to, some people use the phrase, clear the denominators. I'm trying to produce an equation that has no fractions in it at all, because those are much easier to solve. So by multiplying by the LCD, I'm going to create an equation with no denominator. So here's how it works. Much like we did in our previous lesson, I'm going to divide my blue denominator, 2 times x minus 1, into this LCD. And if you notice, if I did that division, the 2 would cancel, and the binomial x minus 1 would cancel, leaving this binomial x plus 1 as part of my LCD. So, much like the previous lesson, the part that did not cancel in this division process, I'm going to multiply times this numerator 5. When I multiply 5 times x plus 1, I get 5x plus 5. Okay, moving over to the right side, I'm going to do the same thing. Remember, whatever I do to one side of an equation, I have to do to the other side. So notice that the x plus 1's would cancel, they match up. The x minus 1's would cancel when I divide. The only thing that doesn't cancel is 2, and I'm going to multiply that 2 times 15 and get 30. So what I've done is I've taken an equation involving rational expressions, rational just means fraction, and my green equation is now the one that I'm going to be solving. It has no fractions. So I have cleared, notice I have no fraction, no denominators in this equation, and this is really pretty simple to solve. I just subtract 5 from both sides, divide by 5, and I get my answer, x is 5. Now, one thing you should check, the directions tell you to check each solution, and you should verify that if I do let x be 5, both of these x's, do I get 0 as a denominator? And if that were the case, then 5 really could not be a solution after all. But I don't get 0 if I let either of these x's be 5, but it's something that you should at least visually check and make sure of. Okay, so our final answer here, x is 5. Let's try another one. This is already factored for us, so I'm going to recognize the LCD as 5 times x plus 2. And I'm going to multiply by the LCD on both sides of the equation. Okay, so here I'm going to divide. I'm dividing blue into green, and everything cancels. And that means I've got 1. And 1 times negative 4 is negative 4. Okay, move over to the other side. If I divide blue into green, the x plus 2's would cancel, leaving 5 times 3, which is 15. Well, this is an interesting case. I have no variable, and the expression that I'm left with is false. Negative 4 does not equal 15. So therefore, since my expression is false, that means in this particular case I have no solution. Alright, let's move right along. Looking at the denominators, neither of these can be factored. So my LCD is x plus 3 times 2x minus 1. X plus 3 times 2x minus 1. If I divide blue x plus 3 into my common denominator, notice what doesn't cancel. 2x minus 1 doesn't cancel, and that's what multiplies times this numerator. And if I multiply 2x minus 1 times 4, I get 8x minus 4. Okay? On the right side, if I divide blue into the green LCD, the 2x minus 1's cancel, leaving x plus 3 to multiply times 10. That's 10x plus 30. And I've cleared the denominators. Okay? Now I have a really simple equation to solve. Subtract 8x, subtract 30, divide by 2, and my final answer here, I think, is negative 17. Just a quick look. Negative 17 doesn't create 0 in either denominator, so we're good. Alright? Now, when you get to numbers 10 through 21, the problems look a little bit different. The equations are not just one fraction that equals another fraction, but the way we go about solving these is exactly the same. Let's find the LCD. I have x and 5x, so hopefully you can see that the LCD is 5x. That is the lowest number term that both x and 5x can divide into evenly. Alright, so now let's work on clearing these denominators. Dividing 5x, or x into 5x. Well, if we did that, these x's would cancel, and that leaves 5 times 5, which is 25. I've had some people stumble on this part, but let's just think of this the same way. Put the x back. You've got really two ways to think about this, but let's just be consistent and go through the same procedure. 5 really has a denominator of 1, so if I divide 1 into 5x, I get 5x, and then 5x times 5 is 25x. Or you may have just thought of, well, let's just multiply 5x times 5, and that is 25x. So either way. Okay, divide 5x into 5x, that's 1. 1 times 6 is 6. So we have cleared out, removed all the denominators, and we're left with a pretty simple equation that we solve for x, and we know how to do this. So my final answer, negative 19/25. Check for 0 in a denominator, doesn't happen. So there is my answer for number 4. Number 5, same procedure. Looking at the denominators, the lowest possible number that 2, 3, and 6 will divide into is 6. So I'm going to multiply by 6 on both sides of the equation. So divide 6 into 6, that's 1. 1 times 3x minus 1, of course, is 3x minus 1. Okay. 3 into 6 is 2. 2 times 2 is 4. On the right side of the equation, divide 2 into 6, and that's 3. 3 times 5 is 15. Okay, combine like terms. Isn't it great to not have to work with fractions? And multiplying by the LCD on both sides allows us to remove these denominators. Basically get lost inside this LCD. Okay, 3x equals 12. Our final answer here, x equals 4. We don't have to worry about 0 in any of these denominators because there are no variables in the denominator. So that's our answer. Number 6. Same thing. I look for factoring. There is no factoring that can be done. So my LCD will be a combination of these factors, x times x plus 1. Do that on both sides. Okay, notice how if I divide red x denominator into the LCD, these x's would cancel, leaving x plus 1. And now multiply x plus 1 times 4, 4x plus 4. Okay, same thing here. If I divide x plus 1 into this LCD, the x plus 1s would cancel, leaving this x. And what do I do with the x? I multiply times the numerator. That's minus 3x. On the right side, there's really, you could divide by 1, but all I really need to do is put this together using multiplication. And hopefully you can see the presence of this x squared means we're going to have a quadratic equation. So let's go ahead and combine like terms, 4x minus 3x. Okay, and in the process of getting the x's, the x terms on the same side of the equation, I hope you see that they're just going to cancel each other. Alright, so you really have two ways of going about this. I could let this equal 0 and factor to get my two solutions. Remember, anytime you solve a quadratic equation, you should come up with two solutions. And it looks like our two solutions are -2, +2. Or at this point, you could have solved by square roots. Just remember, when you do the square root of both sides of the equation, you have to include plus minus, and that would have also given you +2 and -2. Quick check, does either one of those numbers, 2 or -2, make 0 in the denominator? And the answer is no. So we are good to go. Okay, a couple more. My LCD is 4x. Let's show that being multiplied on both sides. Let's first divide. 4 into 4x goes x times 5x is 5x squared. Okay, divide x into 4x, that's 4. 4 times 3 is 12. We're subtracting 12. And then on the right side, if we divide 4 into 4x, these 4's would cancel. X times 1 is x. So it looks like we got another quadratic. So this time I'm going to let this equal 0, and I notice that I cannot factor this because there are no factors of -60x squared. That's what the two n terms would multiply to. No factors of -60x squared that add up to -1x. So since factoring is not going to work, I'm going to have to use either the quadratic formula or completing the square. And I'm going to use the quadratic formula, opposite of b, that's the opposite of -1, plus minus the square root of b squared, -1 squared is 1, minus 4 times a times c, all over 2 times a, which is 10. So let's go ahead and simplify this radical. That's going to be the square root of 1 minus, if you do this, 20 times -12 is -240. Okay, So we got 1 plus minus the square root of 241 all over 10. I don't have my calculator with me at this moment, but hopefully you do. In cases like this where we can't factor, when we use the quadratic formula, we're going to end up with a decimal answer. I think the square root of 241 is something like 15 point something, 35 or something like that, 57. I could be off just a little bit. I'm trying to go from memory. But here's how you're going to find your two answers. You need to do 1 plus 15.57, which would be 16.57 divided by 10. And that'll give you one answer. And then you need to do the subtraction. 1 minus 15.57 divided by 10. And if I remember correctly, we're going to round these to two decimal places. Your two answers are positive 1.65 and negative 1.45. Okay, so just a reminder, do the addition, divide by 10 for one answer, do the subtraction, divide by 10 for the other solution. And neither one of those makes 0. Okay, this is our last example. Let's see if we can find an LCD out of all this, the lowest possible term that all four of these can divide into evenly. And it looks like that's going to be 12x. The lowest number that both 3 and 4 will divide into is 12. And I've got to include x as my LCD because otherwise I could not divide two of these denominators into the LCD. Okay, so I'm going to multiply both sides of the equation by 12x. If I divide 3x into 12x, that's 4, and then 4 times 4 is 16. Okay, moving right along. If I divide 4 into 12x, that's 3x. And then 3x times 3 is 9x. Okay, that clears out the denominators on the left side. Now let's clear them out on the right side. If you divide x into 12x, that's 12. Okay, just think of it this way. These x's would cancel. And now 12 times 1 is 12. Alright, so hopefully you saw that. Now let's do the same thing here. 3 into 12x is 4x, or 12x divided by 3. And now 4x times 2 is 8x. Alright, and now it's just a matter of getting the x terms together on one side. So I'm going to add 9x to both sides. I'm going to subtract 12 on both sides. Solving for x, I get 4/17. And that does not create a 0 in either one of these denominators. And so that is our final answer. Okay, I hope that's given you enough examples. It's a lot of repetition. Pretty much the same way to solve all 21 of these homework problems for tonight. So I hope this has helped you. But if not, you're welcome to send me an email, bring your questions to academic support, and then we'll check them out tomorrow.